Hello students, welcome to Anne's classes. Let's do cube and cube roots exercise 4a. This is found on page number 53 and we are with the multiple choice type. Choose the correct answers from the options given below. Question 1, the cube of 0.5. Now we have studied squares, isn't it? Now we're going to study cubes. Now what is the cube of any number? When you multiply that number 3 times by itself, it is called the cube. So here now the cube of 0.5. Now 0.5 is a decimal number. 0.5, isn't it? Now we have learned how to multiply decimal numbers. Now what do? We remove the point and we multiply. And then we put back the point. So this is 0.5 into 0.5 into 0.5 when we are talking about the cube of 0.5. Here let's remove the decimal point. So when you remove the decimal point, this number becomes 5 into 5 into 5. So let's write that. So this is 5 into 5 into 5. Let's multiply. 5 5s are 25, 25 5s are 125. Now what we do is we go back to the question and count how many decimal places there are. That means after the point, how many digits do we have? After this, we need to see that the answer also has the same number of decimal places. So let's count. So here we have one decimal place, 1, after the point 1 more, after the point 1 more. So totally we have 3 decimal places. That means in your answer also you should have 3 decimal places. So the point will move from right to left. So this is one place, second place, third place, and the point comes here. And here before that there's no number, so we write 0.125. So that is our answer, 0.125. And let's check our options. In our options, option B is 0.125. So this is our answer, 0.125. Question 2. The cube of minus 4 is. Now minus 4 is a negative number. So let's keep this point in mind. The cube of a positive number is positive and the cube of a negative number is negative. That means the cube of minus 4 is going to be negative. So when we say minus 4 cube, we can write this as minus because we know the answer is going to be negative and multiply only the number, that is 4 into 4 into 4. So this is minus 4 fours are 16, 16 fours are 64. So the answer here is minus 64. Which option is that? That is option C. Option C is minus 64. So this is our answer. Question 3. The smallest number by which 72 must be multiplied to obtain a perfect cube is which of these numbers? So we have to find all the prime factors of 72 first. So let's do that. Let's find the prime factors of 72. So let's begin with 2 itself. So this will be 2 3s are 6. This one left. 12. 2 6s are 12. Now again with 2 we can do 2 1s are 2. There's one left. It's 16. 2 8s are 16. 2 9s are 18. Now we can use 3. 3 3s are 9 and then 3 1s are 3. Now the prime factors of 72 will be all these numbers here, that is 2 into 2 into 2, and we have 3's also, 3 into 3. So first thing we do is find all the prime factors and then write all the prime factors here. Now since we are talking about a cube, remember we're talking about 3 numbers. So we're going to put them into groups of 3. So let's see here. Here we have one group of 3, all the 2's like primes, identical prime numbers. So all groups of 3, now of 2. So we have groups of 2 here. We have 3 in this group. Now here we have 2 3's, but we have another 3 missing. We need one more 3 to make up this group. So that means the smallest number by which 72 must be multiplied. 72 has to be multiplied by 3. Only then you can get a perfect cube. So this is the smallest number, 3. And that is option A. So that is our answer, 3. Question 4. The smallest number by which 81 must be divided to obtain a perfect cube is one of these. So what we're going to do is we're going to find again the prime factors of 81. So let's do that. Prime factors of 81. We're going to use 3 this time. So divide 81 by 3. 3 twos are 6. And then you have 2 left, 21, 3 sevens, 9s are 27. So 3 9s are 27. Then again we have 3 3s are 9. And then 3 1s are 3. Now let's put all the prime factors of 81 together. So the prime factors of 81 are 3 into 3 into 3 into 3. So how many 3's do we have there? We have 4 3's. We're going to put them in groups of 3 each. So we can only make one group, isn't it? So we're having one group where we have 3 3's, whereas there's 1 3 left. So this is the smallest number by which 81 must be divided to obtain a perfect cube. So answer is 3 and that is option B. So option B, 3 is our answer. Question 2. Find the cube of all these numbers. Find the cube of this. That means we multiply this 3 times. So let's do that. So this will be 7 into 7 into 7 to find the cube of 7. So 7 sevens are 49. And 49 into 7 is 343. So this is our answer. The cube of 7 or 7 cube is 343. Next one is find the cube of 11. Multiply 11 3 times. 11 into 11 into 11. So 11 into 11 is 121. 121 into 11 is 1331. So you have to multiply all these children and get your answer. The easiest way is you know the square of your numbers, isn't it? 11 square is 121. So multiply 121 into 11. Similarly here 7 2 times 7 square we know is 49. Multiply into 7. 49 into 7. So it makes it easier. So now the next one is the cube of 16. So this is 11 cube. Now this is 16 cube. That is 16 into 16 into 16. Now when you multiply 16 into 16, you get 256. Multiply that into 16. So what do you get? 4096. So this is your answer, 4096. Get the square of 16 and multiply that with another 16. Next one, now the cube of 23, that is 23 into 23 into 23, 3 times. Now 23 into 23 is 529. Now when you multiply that with again 23, the answer that you get is 12,167. This is the answer. This is the cube of 23. Now 31. Next one is 31. We have to find the cube of 31. So that is 31 into 31 into 31. 31 into 31 is 961 and then you multiply that with 31 once more and the answer that you get is 29,791. So this is the answer. Next one is 42 cube. So that is 42 into 42 into 42, 3 times. 42 into 42 is 1764. You multiply that with 42 and the answer that you get is 74,088. So this is our answer. Next one is 54 cube. So that is 54 into 54 into 54. First, you multiply 54 into 54 and you get 2916 and then multiply it with this 54. And then the answer that you get is 1,57,464. So this is the answer and this is the cube of 54. Question 3. Find which of the following are perfect cubes. So we're going to see if this is a perfect cube. Now how do we do that? We find the prime factors of 243 first. So let's do that. Let's find the prime factors of 243. Let's divide this by 3. 3 eights are 24. 3 ones are 3. Continue. 3 twos are 6. There's 2 left. 21. 3 sevens are 21. Then 3 nines are 27. 3 threes are 9. And 3 ones are 3. So we have found all the prime factors. Now let's write it down. Now 243, the prime factors are all these threes. Let's count. 1, 2, 3, 4, 5. So let's write them down. 1, 2, 3, 4 and 5. Then since it is the cube, we are going to put them into groups of 3. So here we have 3. This is one group. It's called a triplet because there are 3 in it. Now here there are only 2. So we cannot form a triplet because there's one missing. So there's only one set of triplets here. And if you have something left like this without being able to form a triplet, that means this number is not a perfect cube. Okay, so it's understood that 243 is not a perfect cube because it doesn't have another number here to form a triplet. So for this answer, 243 is not a perfect cube. Question 3, the second one. Let's see if this number 588 is a perfect cube. So let's find the prime factors of 588. So 588 is an even number, so we can divide it by 2. 2 twos are 4, there's 1 left, 18, 2 nines are 18, 2 fours are 8. Again with 2, 2 ones are 2, then we have 9, 2 fours are 8. There's 1 left, 2 sevens are 14. Now 147, is this divisible by 3? Let's do the test for 3. Add it up and see if it is in the tables of 3. 1 plus 4 is 5. 5 plus 7 is 12. Yes, it's in the tables of 3. That means this is divisible by 3. So let's divide it by 3. We have 14. Let's take 3 fours are 12. And there is 2 left, 27. 3 nines are 27. Now let's take 7. 7 sevens are 49. 7 ones are 7. Now let's write down all the prime factors of 588. We have 2 twos, we have a 3, and we have 2 sevens. As you can see, children, we are not able to form triplets with any number. We can't form with 2 because there are only 2 twos. We cannot form with 3 because there's only 1 3. We cannot form a triplet with 7 because there are only 2 sevens. So we need, remember, triplets. We need groups of 3. 3 twos, 3 threes and 3 sevens. Now since we don't have any triplet here, 588 is also not a perfect cube. Question 3. Let's try and see if this number 1331 is a perfect cube. So let's divide this 1331. Let's find the prime factors. Let's divide this with 11. So 11 ones are 11, 12, 13. There is 2 left, 23. So 11 twos are 22. There's 1 left, 11. 11 ones are 11. Then here 11, we know the square. 11 elevens are 121 and 11 ones are 11. So let's write down the prime factors of 1331. That is 11 into 11 into 11. So as you can see, this has formed a triplet and we don't have any extra number left. So whatever factors we have, we are able to form a triplet of identical factors. They're all 11 and there are 3 11s. That means this number 1331 is a perfect cube. So we can write that 1331 is a perfect cube. Question 4. Now here we have 24,000. Let's see whether this is a perfect cube. Let's find the prime factors of 24,000. So 24,000, we can use 2 again. Let's divide with 2. 2 ones are 2, 2 twos are 4. Again you have 3 zeros. Continue with 2. 2 sixes are 12. 1, 2, 3 zeros. 2 threes are 6. Now we can use 3. We can use 2 also. Let's use 3. Now we can use 2, 2 fives are 10 and then put 2 zeros. Again you can use 2, 2 twos are 4, 2 fives are 10, 250. Again you can use 2, 2 ones are 2, 2 twos are 4, 2 fives are 10. Now let's use 5. 5 2s are 10, 5 5s are 25, use 5 again, 5 5s are 25, and we have 5 1s are 5. So now so many factors are there. So let's write down all the factors of 24,000. Let's get all the 2's together first. So we have 1, 2, 3, 4, 5, 6. So let's put all the 2's together. So 1, 2, 3, 4, 5, 6 2's. Now let's look at the 3's. We have only one 3. From here itself you can make out that this is not going to be a triplet. So into 3 we have only one 3. Now let's count and see the 5's. So here we have 1, 2, 3 5's. So that is into 5 into 5 into 5. Now let's form all the triplets. So here we have one set of triplets. Here we have another set of triplets. And here also we have a set of triplets. But can you see 3 is there? 3 is alone by itself. It is not forming a triplet. So when it doesn't form a triplet, the number will not be a perfect cube. So 24,000 is not a perfect cube. Question 5. Let's find the prime factors of 1728. So here let's begin by saying 1728. It's an even number. So we can divide it by 2. Let's take 17. 2 8s are 16. 1 is left. 2 6s are 12. 2 4s are 8. Let's continue with 2. 2 4s are 8, 2 3s are 6, 2 2s are 4. Continue with 2. 2 2s are 4, 2 1s are 2, there's 1 left, 2 6s are 12. Continue. 2 1s are 2, then 0, 2 8s are 16. Continue. 2 5s are 10, 2 4s are 8. Again, 2 2s are 4, there's 1 left, 7, 2 7s are 14. Now we're going to use 3. 3 9s are 27, 3 3s are 9, and 3 1s are 3. So now let's write all the prime factors of 1728. Let's take all the 2's first. So we have 1, 2, 3, 4, 5, 6. We have 6 2's. So 1, 2, 3, 4, 5, and 6. Now let's take all the 3's. We have 1, 2, 3. So that is into 3, and one more 3. Now let's put them into groups of 3, make a triplet. 1, 2, 3. We've got 3 triplets there. There is no number left by itself. That means 1728 is a perfect cube. So let's write our answer. 1728 is a perfect cube. Next one, let's find out if 1938 is a perfect cube. So let's write that down. So 1938. Let's divide this by 2. Let's take 19. So that is 2 9s are 18. There's 1 left, 13. 2 6s are 12. Again, there's 1 left, 2 9s are 18. Now we divide it by 3. 3 3s are 9. 3 2s are 6. 3 3s are 9. Now this 323 is divisible by a prime number, that is 17. So 17 ones are 17. Then you subtract. So let's do that division here. We'll do long division. So 17 ones are 17. And then what is left? So here we have to borrow 2, 12. 12 minus 7 is 5. 2 minus 1 is 1 and 3. Now 17 into 9 is 153. So we get 19. So here it is 19, and as you can see 19 is also a prime number, so we have to divide this 19 by 19. So divided by 19 and it is 1. Now the prime factors of 1938 are 2 into 3 into 17 into 19. So as you can see children, we are not able to form triplets with any of these numbers. That means 1938 is not a perfect cube. Question 4. Find the cube of the first one, 2.1. That means we are going to multiply this 3 times. So the cube of 2.1 is 2.1 into 2.1 into 2.1. So what we're going to do is we're going to ignore the point and multiply. So that will be 21 into 21 into 21. So first we multiply 21 into 21. That is the first two numbers. So when you multiply that, you get 441. Now you multiply it with the third one. So we get 9,261. Now we need to go back to the question and see how many decimal places we have. So let's count and see. After the point, there's one decimal place, 1, 2, 3. So after the point, there are three decimal places. That means in our answer also, we should have three decimal places. So after the point, we should have three places. That means our point will come here. So now can you see 1, 2, 3 decimal places that are in this number. So what is our final answer? Let's write it here. 9.261. This is our final answer. Question 2, 0.4. The cube of 0.4 will be 0.4 into 0.4 into 0.4. Now let's multiply these decimals by ignoring the decimal point. 4 into 4 into 4. So let's multiply the first two fours. 4 fours. 4 fours are 16 into 4 is 64. Now let's go back to the question and check the number of decimal places that are here. So here we have 1, 2, 3 decimal places. So your answer also should have 3 decimal places. Now remember, the point is moving from here backwards when you place the decimal point. So we should have 3 decimal places. Here we have 1, 2, we should have one more decimal place and then only the point comes. So that means in this place we should put a 0. Okay, so before the point, there is no number. So there also we can put a 0. So what is our final answer? 0.064, which we can write here. So let's write that here. The final answer is 0.064. Next one, we should find the cube of 1.6. So the cube of 1.6 will be 1.6 into 1.6 into 1.6. Now let's ignore the point and multiply. So that will be 16 into 16 into 16. So multiply the first two 16. 16 into 16. That we know is 256. That's a square, isn't it? So into this 16. You will get 4096. You have to multiply all this carefully, children. So now we have 4096. Let's go back to the question. Check the number of decimal places. So we have 1, 2, 3 decimal places. Your answer also should have 3 decimal places. So the point comes here. So 1, 2, 3. So what do we have? 4.096. So let's write it here. 4.096. This is our answer. Next question, the cube of 2.5. So let's write that. So this will be 2.5 into 2.5 into 2.5. Let's ignore the point and multiply. 25 into 25 into 25. Let's multiply this. 25 into 25. That is 625 into 25. So what is the answer that you get when you multiply this? We get 15,625. Again, let's go back to the question. Count the number of decimal places. So here we have 1, 2 and 3. In our answer also we should have 3. So 1, 2 and 3. So the point comes here. So what is our answer? 15.625. So this is our final answer, 15.625. Question 5. Again, find the cube of 0.12. So the cube of 0.12 is 0.12 into 0.12 into 0.12. So let's ignore the point and multiply 12 into 12 into 12. So we know 12 into 12 is 144. Now we multiply that by 12, which is 1728. Now look at the question and count the number of decimal places. So here we have 2 plus 2 plus 2. 2 plus 2 is 4, 4 plus 2 is 6. There are 6 decimal places. That means in our answer also there should be 6 decimal places. That means we have to put a point, and after the point there should be 6 places. So let's move backwards to get 6 places. So here we have 1, 2, 3, 4. We need to have 2 more, 5, 6, and then the point. So in these places we put zeros. So now what is our answer? Now here also, now when there is no number before that, you can put a 0 before that. So what is your final answer? Our final answer, let's write it down here, is 0.001728. So this is the cube of 0.12. Question 6 is the cube of 0.02. Cube of this will be 0.02 into 0.02 into 0.02. So when we ignore the point, what do we get? 2 into 2 into 2. Now 2 2s are 4. 4 into 2 is 8. So the number that we have here is 8. But look at the question and see the number of decimal places. Now here 1, 2, 3, 4, 5, 6. That means here also we should have 6 decimal places. So here we have only one digit. We need to have 5 more. 1. So that makes it 2, 3, 4, 5, 6. And then only the point comes. So in all these missing places, we have to put zeros. And even here before this, we put a 0. So that becomes 0.000008. So let's write that answer here. So we have 0 with 5 zeros and an 8. So this is our answer. So you have to remember to put the point correctly in the right place. Question 7, the cube of 0.8. So we have to write that 3 times. 0.8 into 0.8 into 0.8. So that will be 8 into 8 into 8. We are ignoring the point and multiplying. Now let's multiply 8 into 8. 8 8s are 64. 64 into 8 is 512. Now let's go back to the question and look for the decimal places. So after the point, how many places are there? There is 1, 2 and 3 decimal places. That means our answer also should have 3 decimal places. Now let's mark the places. So we have 1, 2 and 3 and the point comes here. And since there's no number before the point, we can put 0. So what is our answer? Our answer is 0.512. So this is the answer. So we will stop with this for now, children. In our next video, we will continue with the remaining questions. Thank you, children.